Hi, hello, welcome to Homeschool. This is your class 10 mathematics. Today in this session, I am going to explain you all the theorems which are important for your annual examination. These theorems occurs from two chapters, triangles chapter and also circles. The weightage for these theorems will be 1 mark, 1 3 marks, and 1 it may be 4 or 5 marks. Total 1 plus 3 4, 4 plus 4 8 or 9 marks. Total 8 to 9 marks weightage will be there only for theorems. In 1 mark they may ask the statement of the theorem, and in 3 marks one theorem is compulsory, that will be only from circles chapter. In circles there are two theorems, among that any one will come for 3 marks. Coming to 4 or 5 marks, there are 4 theorems which are very important in triangles chapter. Among those 4, any one will come either for 4 marks or 5 marks. So total for these theorem 8 to 9 marks. So what are the theorems we can expect here? First one, basic proportionality theorem or Thales theorem. Basic proportionality theorem B.P.T or Thales theorem. Second one, angle similarity criteria theorem. Third one, areas of similar triangles. Coming to fourth one, Pythagoras theorem. Among these 4 theorems, one theorem will be coming for 4 or 5 marks. Then coming to next 2 theorems, theorem 4.1 and another theorem 4.2. If you want to remember, you can remember here radius is perpendicular to tangent. You remember this theorem. And theorem 4.2 will be tangents from an external point should be equal. Tangents, you remember. Okay, these are very important 6 theorems which occur for your annual examination. So these 4 theorems we can expect for 4 to 5 marks, and these two, among these two, one will be for 3 marks. And coming to 1 mark, they may ask you state basic proportionality theorem or state Thales theorem. State in the sense only statement we need to write. State Pythagoras theorem, state converse of Pythagoras theorem. We have converse of these theorems also, but only statement is needed. Theorem is not important for this year 2021 examination. Let's start our theorems. Before starting theorems, I would like to say you 5 points which are very important in writing a theorem. First point is statement. Second one, data, what is given in the statement. Third one, what to prove. Fourth one, construction if anything there. And fifth one, it is proof. With this 5 steps, we should complete the theorem. Okay, these 5 steps are very important in order to score marks. Let's start the first theorem. Theorem 2.1. This is only the basic proportionality theorem or B.P.T theorem or Thales theorem. Right? First step, statement. If a line is drawn parallel to one side of a triangle. I have drawn a triangle here. Triangle A, B, C. How many sides it have? 3 sides. AB, BC, CA. Draw a line parallel to any one side. So let me draw a line here parallel to BC. And mark the point DE. If a line is drawn parallel to one side of a triangle to intersect the other 2 sides. Where is this line intersecting other 2 sides? Intersecting at point D and point E. Intersecting other 2 sides in distinct points. That distinct points we have marked it as D and E. The other two sides are divided in the same ratio. Extra line which came out I have cleaned up here. And again let's repeat the statement. If a line is drawn parallel to one side of a triangle to intersect other two sides in distinct points D, E, and the other two sides are divided in the same ratio. Okay, let's start the second step of the theorem. It is data. What is given? Given a triangle, right? We have marked ABC. Given triangle ABC and DE is a line parallel to BC. ABC is a triangle given and DE is a line parallel to BC given. Next point, to prove. What we need to prove? The other two sides are divided in the same ratio. That means to prove AD by DB is equal to AE by EC. Next point, construction. Join BE, join DC and do perpendicular on line AC. Mark it M, DM perpendicular to AC and do one more perpendicular from E and mark this as N. EN is perpendicular to AB. Join BE, join CD and DM. DM is perpendicular to the line AC. EN is perpendicular to the line AB. See here, this is a perpendicular on this complete side. Join BE and DC. Draw EN perpendicular to AB. Observe here, I am not ending with AD. I am ending with AB. EN perpendicular to AB and DM perpendicular to AC. Proof. Before starting proof, I am going to take a rough figure which you need to understand and then erase this figure. Or if you want, you can observe from this figure itself. I need only the perpendicular on this line. What is perpendicular? EN is perpendicular. Right? I am going to consider the triangles ADE and the triangle BDE. Okay? So I am not taking another perpendicular. See the figure, observe carefully. Consider triangle ADE and triangle BDE. Which two triangles I am taking? ADE triangle and BDE triangle. We need to calculate the area. Area of triangle ADE. In shortcut, you can write it as area of triangle ADE. Okay. What is the area of a triangle formula? Half into base into height. If you want, you can write here. Since area of triangle, area of any triangle is equal to half into base into height. Okay. Now, area of triangle ADE. What is area of triangle ADE? Is equal to half into area of triangle ADE base. Immediately you say it is DE. No, please observe your base from this side. And say for this triangle, what is the base? AD. Only this triangle ADE. AD is the base and EN is the height. Half into AD into EN is the height. Half into base into height. Next, consider another triangle area, that is area of triangle BDE. Area of triangle you can write, or area of BDE is nothing but area of triangle BDE is equal to half into, see this triangle, base. From this side you see the base, DB. into height. What is the height on this line? EN is perpendicular to AB. Though EN is not there in this triangle, but this is only the perpendicular, right? When we say height, you need to write EN. Now, divide these two equations, 1 and 2. On dividing equation 1 and 2, area of triangle ADE by area of triangle BDE. LHS side you divide, RHS side. Half into AD into EN by half into DB into EN. EN cancel, half will be cancelled. You are left with area of triangle ADE by area of triangle BDE is equal to AD by DB. Mark this as third equation. Okay. First step what we have taken? This triangle and only this triangle. Next, take again this triangle and this triangle. So look here. What you need to consider in our rough figure? A, B, C. And again a parallel line. DE parallel line. Okay. And on AC, where is the perpendicular? DM. Okay. DM is perpendicular to AC. And here, this side over and this side, which triangle you can see? DEC. See the figure in this way. And in the second case, again ADE triangle and DEC triangle. Same manner, we are going to find the area. Now, consider triangle ADE and triangle DEC. Consider triangle ADE and DEC. Only this triangle I am talking and this triangle. Area of triangle ADE. There you do the mistake here, children. What you know that ADE, already you have written AD into EN, you will write. But please don't do that. There at that time you are considering only this side of a triangle as a base. Now when you consider this, you need to consider this side as a base. So only for this triangle if I talk, AE is the base. Area of triangle ADE is equal to half into base AE into height. DM is perpendicular, right? DM is the height. And next, coming to another triangle, area of triangle DEC. Half into DEC triangle, what is the base? EC into height. Though height is not there on this, but complete line, what is the height? DM. So write same one. Now mark this as 4 and 5. Okay. On dividing equation 4 and 5. Divide these two. Area of triangle ADE by area of triangle DEC. Area of triangle DEC is equal to half into AE into DM by half into EC into DM. DM cancel, half of cancel. You are left with area of triangle ADE by area of triangle DEC is equal to AE by EC. Mark this as 6th equation. Okay, now compare this one and this one. Compare 3rd and 6th. What you can see? Area of triangle ADE, area of triangle ADE. Area of triangle BDE and area of triangle DEC. Now observe these two triangles. BDE and DEC are lying on a same line DE. Area of triangle BDE and area of triangle DEC are on same line DE. Are lying on same line DE, you can write, and are in between two parallel lines. Therefore, area of triangle BDE is equal to area of triangle DEC. So they are lying on a same line and in between two parallel lines. Therefore, this triangle equal to this triangle. So according to that, what I can say, when I compare 3 and 6, ADE, ADE. And now according to this, BDE is also equal to DEC. So this ratio and this ratio is equal. By axiom 1, what I can say, I can equate those two. Okay. Therefore, on comparing 3 and 6, I can say that AD by DB is equal to AE by EC. Therefore, hence it is proved. What it is proved? The other two sides are divided in the same ratio. AD by DB is equal to AE by EC. If a line is drawn parallel to one side of a triangle, then the other two sides are in proportion. So this is your basic proportionality theorem, and I would like to explain this theorem within two lines. Yes, it is very easy. So look here carefully, only the two lines which are shortcut to remember. That is area of triangle ADE. Area of triangle ADE by area of triangle BDE. What it will be? Half into base AD into height EN by this triangle, half into base DB into height it is EN. EN cancel, half of cancel. So again, next ratio, consider this triangle and this triangle. Area of triangle ADE by area of triangle DEC is equal to half into base AE, height on this line is DM, by half into EC into DM. DM cancel, half of cancel. On comparing these two triangles are lying on a same line and between same parallel lines. Therefore, these two triangles area equal. Therefore, what happens? These two ratios will be equal. If they are equal, by axiom 1, what I can say? AD by DB is equal to AE by EC. Angle similarity criteria. What is the statement? If in two triangles, every word we split here. Two triangles, see here, I am going to consider two triangles here. They look similar, but were they really similar? What is the rule, children? You should know. If they are similar, their corresponding angles must be equal and the sides must be in proportion. So the same thing we need to prove here. But in this theorem, corresponding angles are equal given. Let's read the statement. Corresponding angles are equal. If in two triangles, corresponding angles are equal, then which type of a triangle it is? It is an equiangular triangle. Okay, if two triangles, corresponding angles are equal, then we call them as an equiangular triangle. Then their corresponding sides are in the same ratio. Then their corresponding sides are in the same ratio or proportion, and hence the two triangles are similar. So here you have to understand the statement carefully. Given data, only first line is given data and rest of the lines you need to prove them. So what they have given, corresponding angles are equal, what we need to prove, corresponding ratios are in proportion. If they are in proportion, we say that the two triangles are similar. Okay, let's start here. So we start with the data. What is the data given here? In your textbook, children, they have considered two triangles. See here, no need of by hearting these triangles also. As you wish, you can take triangles of your variables or any letters you can take. Okay, so you may take this triangle big, that triangle small, like that also you can take, but understand the concept carefully. So I have taken two triangles. So data given, any two triangles set, given. So we have taken here, given triangle ABC and triangle DEF. In this, what they have given, corresponding angles are equal. That means angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. This is the meaning for corresponding angles. Now coming to your construction. Did we do any construction? Yes, we have done. What is that construction here, children? Mark a point P on DE such that, how you need to mark? You have to mark a point on this triangle P. How you need to mark? Such that this length must be equal to this length. That is, AB is equal to DP. Okay. Then one more point we need to mark. What is that, children? Same manner, mark a point Q on, what is that side? DF such that, what you need to write here? Such that AC is equal to DQ. So once again, mark a point P such that this length should be equal to this length. And mark a point Q here such that this length is equal to this length. And now, one more line, what you need to write here? Join PQ. Join PQ. Next, what I need to prove here? Ratios are in proportion. See here, children, ratios are in proportion set. Any type of ratio, small triangle by big triangle or big triangle by small, you can prove. So let me take here AB. What is the corresponding side? That side DE is equal to BC. Can you observe on the figure? BC by EF is equal to CA by FD. See here, always if you are going in this pattern, you have to go other triangle also this pattern. Suppose if I say AB, don't say ED. AB by DE, BC by EF, CA by FD. Okay, don't change any letters. Okay. So now, how do we start a proof? So, how do we start here, children? How can I prove they are in proportion? So, I'm going to give you a hint first. So, how we are going to give? I'll give you an idea. So, now, what we know, children, angles are equal. So, we have taken such that this is same. We are going to prove congruency here. Do you remember the postulates what you have learned in your previous classes? So now, so this angle is same, this angle same, and this side is same. How? By construction. We have done the construction in such a way that this equal to this and this equal to this. Look here, AB is equal to DP and AC is equal to DQ. Yes or no? So side, angle, side. Side, angle, side. Then the two triangles are congruent. Do you know what is CPCT? Corresponding points or corresponding parts of congruent triangles. by CPCT, what you can say? So if these two triangles are congruent, if you able to prove, already we had proved by SAS postulate, right? Then these angles are also equal. Okay, so if they are equal, what can I say? Observe the point here carefully. First, given data, angle B equal to angle E. Now by CPCT, what I can say? Angle B is also equal to angle P. Then look here, the angle B is common for these two equations. So directly you can equate angle P is equal to angle E. That means corresponding angles are equal. Yes or no? So one above the other, corresponding angles are equal. Then the lines are parallel. If they are parallel, what you can say, children? The ratios are in proportion. Equate this ratio here. dP by dE is equal to PQ by EF is equal to DQ by DF. But in the place of dP, you substitute AB. Okay, so just a hint I gave you. Let's start the proof. So here, how do we prove here? Consider triangle ABC and triangle DPQ. Consider triangle ABC and triangle DPQ. So now, what's the given data? You know, right? So in that all the three angles are equal. So while I am proving, I'll consider the above two triangles here, children. And then I say here, angle A is equal to angle D. Why big angle I have written here? The concept you need to observe is only the middle letter. Okay, angle A is equal to angle D. Yes, so first write this letter, then write the other two letters, right? Angle BAC, then this one will be angle PDQ. Okay, so how it is? Reason you have to write now? By given. So now next, AB is equal to DP and AC is equal to DQ. How, children, this one? By construction. By construction. We have done the construction such a way that these two are equal. So now what I can say here? Triangle ABC is congruent to triangle DPQ. Do you know the congruency symbol? That will be SAS postulate. How did we prove they are congruent? Due to side, angle, side. By SAS postulate. So one more thing you need to observe when you are proving SAS postulate. What happens, children? Angle should be included between two sides. Okay, suppose let me take these two sides. Okay, the angle if it is here, you cannot prove. The angle must be included in between the two sides. Then only I can prove SAS postulate. Side, angle, side. For another corresponding triangle, side, angle, side. If they are same, then I can say those two triangles are congruent. If they are congruent, what can I say, children? They will be similar. Only the top two triangles. Okay. So now, by CPCT, what can I say? If two triangles are congruent, then you can equate other angles and other sides are also equal. So children, understand here. So first let me show you shortcut, then you can write full form. So now what I need? Therefore, angle B is equal to angle P. Observe here carefully. Angle B is equal to angle P. How you are saying this? By CPCT. What is CPCT? Corresponding parts of a congruent triangle. So now congruent triangles. So now, but what is given here? Angle B is equal to angle E. angle B is equal to angle E. Now compare these two angles, children. These two are common, no? So directly you can equate these two. How we are going to equate here? Angle B is equal to angle P. Angle B is equal to angle E. On comparing, compare these two. On comparing, what you can write here? Angle P is equal to angle E. This equal to this and this equal to this. How you are saying this? By given data. By given data, angle B is also equal to angle E. Therefore, angle P is equal to angle E. Observe here, children. Now the corresponding angles are equal. Then the lines are parallel. Therefore, corresponding by axiom 1, children, do you remember? If corresponding angles are equal, then the lines are parallel. What are the lines here, children? What are the lines here? PQ is parallel to EF. PQ is parallel to EF. Now again, what do you remember? If lines are parallel, you remember B.P.T, right? So, if lines are parallel, you may apply any corollary I'll apply. Okay? In order to compare this, I can't apply B.P.T or I can't apply corollary 1. Either corollary 2 or corollary 3 you can apply. So now, by corollary of B.P.T, what can you say here? I just compare this with dP by dE is equal to PQ by EF is equal to QD by FD. So finally what you can say here, children? dP is also equal to AB, right? So in the place of numerators, I am going to apply this triangle sides. That is AB by DE is equal to BC by EF is equal to CA by FD. Hence, it is proved. What is this, children? It is how it is proved. So, if the ratios are in proportion, look here, corresponding angles are equal given. Therefore, what you can say? Ratios are in proportion. If they are in proportion, therefore the two triangles are similar. Okay, this is your angle-angle similarity criteria or AAA similarity criteria. Both will come under same. Theorem 2.6. The ratio of the areas of two similar triangles. So children, say me, what are similar triangles? When we say the similar triangles, if their corresponding angles are equal and the corresponding ratios are in proportion, then we can say that the two triangles are similar. So what is your first statement here? The ratio of the areas. See here, the complete inside space we call it as a area. Area of this triangle ratio by area of this triangle is equal to the ratio, square of the ratio of their corresponding sides. Square of the ratios of their corresponding sides. What are the corresponding sides, children? Try to identify here. AB, PQ, BC, QR, CA, RP. Right? So, what is your question? Area of this triangle by area of this triangle is equal to square of the ratio of their corresponding sides. Okay? So, given the two triangles are similar. So, let's start our data here. Given, what did they give here? Triangle ABC similar to triangle. What is another triangle there? PQR. If the two similar. What you can say? We can say that corresponding angles are equal and the corresponding ratios are in proportion. So let's write here. So if you want, you can write it here. Corresponding angle, angle A, angle P, angle B, angle Q, angle C, angle R. You can write it here. Angle A corresponding to angle P or angle B equal to angle Q. Angle C is equal to angle R. And their ratios are in proportion. So children, what can I write here? AB by PQ is equal to BC by QR is equal to CA by RP or PR you can write. So now what we need to prove here children? Area I need to prove. Ratio of the areas. So let me write it here to prove. AR is a shortcut for area. Or if you want, you can write area of triangle ABC by area of triangle PQR is equal to square of the ratio of their corresponding sides. Which side can I take here? You may take any side. So here to prove, I am going to give you the three ratios. So what you want to prove, you can decide and you can prove your wish, right? So let me write here. AB by PQ whole square is equal to BC by QR whole square is equal to AC or CA, anything you can write, CA by RP whole square. So what we need to prove children? The ratio of the areas of the corresponding triangles. Area of triangle ABC by area of triangle PQR is equal to square of the corresponding ratios. AB by PQ whole square is equal to BC by QR whole square is equal to CA by RP whole square. So children, try to identify here. At a time you can prove only one ratio. But if in any one ratio if you have proved, it is correct. So let's start our proof. How can we start children here? I need to prove area of the triangles. So immediately what do you remember here? Area, half into base into height. So to find area, what do I need to do here? Let me do a tiny construction. What is that construction here? Draw AL perpendicular to BC. Two altitudes we need to draw here. AM and PN such that they are perpendicular on their respective bases. AM perpendicular to BC and PN perpendicular to QR. In construction, what you are going to write? Construct or draw AM perpendicular to BC and PN perpendicular to QR. Okay. Why we have done children? In order to find the area of a triangle, we need altitudes, right? So we start our proof with finding the area. So now consider the two triangles. Consider triangle ABC and triangle PQR. What do we know children? We know that the two triangles are similar. Right? If they are similar, the corresponding angles are equal and the corresponding ratios are in proportion, we know. But now what I need to find? Let me find the LHS part, that is area of this triangle by area of this triangle. So we know that what is area of a triangle? Half into base into height. So we know area of a triangle is equal to how much? Half into base into height, right? So when we are writing theorem, this side we do with the statement and this side we give the reasoning. How we are writing the statement and due to which formula or which rule we are writing that, we can write here in reasoning. So now consider area of triangle ABC is equal to half into base is how much area of a triangle, observe here, half into BC into height AM. Area of triangle PQR. PQR is equal to how much, children? Half into base. What is the base here? QR. QR into what is the height? Altitude is how much? PN. Okay. Half into base into height. So now what we need to do next step? On dividing. These two areas we need to divide. Why? In your question you have areas of triangles ratio. So for that reason I am going to divide these two equations. So if I divide area of triangle ABC by area of triangle PQR is equal to, so write this, half into BC into AM by half into QR into PN. Okay, half cancel. So now this multiples you split here, children. How we are going to split? BC by QR into AM by PN. Mark it as first equation. Now what did you get? Area of triangle ABC by area of triangle PQR is equal to BC by QR into AM by PN. Now you should think here. Did you get your proof? No. We got only BC by QR only one time there. Means if you multiply one more time BC by QR, then it will be this answer. Right? So in order to multiply, what we need to do? In the place of AM by PN, we need to substitute BC by QR. How, children? Let us see now that, right? So now half of your theorem is completed. So next half. See this, children? Part of a triangle. Okay, I'm going to take only one part of a triangle. Why? I know that full triangle is similar. So, according to that, angles are equal, right? I have drawn the perpendiculars, right? So, this angle is equal. When I compare this small triangle, 90, 90. Angle equal. If two angles, corresponding angles are equal, then I can say that the two triangles are similar. If they are similar, why I am making similar? In order to equate their ratios. So this ratio and this ratio I will take. So when I equate, I have a chance of comparing with the given ratio and then I can substitute. Then I am going to get your answer. So let's see here. So how to start a problem here? Consider triangle ABM and triangle PQN. Observe here, children, I am not taking full triangle, I am taking only part of the triangle. ABM and PQN. Okay. So now from this, what I can say here? Angle ABM is equal to angle PQN. Children, observe here, ABM I am saying. Do this angle end here? No. If you want, you can write angle ABC is also equal to angle ABM. Okay, some children ask me a doubt. Ma'am, ABM or ABC, both are correct. Angle arising at B is important. Right? This angle is important. Where you end your angle letter, Yavish. Angle ABM is equal to angle ABC also you can say. So I am taking this triangle, so I will end my letter here. ABM is equal to angle PQN. How, children? By the given data. right? And one more. Angle BMA is equal to angle QNP. What is the angle we need? Angle M, angle N, you can say. Easy to remember. Angle B equal to angle Q given. Angle M equal to angle N perpendicular. That will be equal to 90 degrees. By construction, I can say this reason. Okay. So now these two triangles are similar. Therefore, triangle ABM similar to triangle PQN. Therefore, triangle ABM is similar to triangle PQN. By which similarity criteria? By angle similarity criteria. I can say that these two triangles are similar. If they are similar, what do you remember, children? Corresponding angles are equal and the corresponding ratios are in proportion. So let me take only these two ratios. Observe here, only these two. AB by PQ is equal to AM by PN. Have a look here. AB by PQ, AM by PN. Can you do anything with this? If you substitute instead of AM by PN, AB by PQ, do you get the answer? No. It should be changed again. AB by PQ should be changed to BC by QR. Okay. So how can I change? Okay. This as it is you keep here. We know. What do we know, children? I take here. We know which two ratios will take. I need to change BC by QR. But I have an above ratio AB by PQ. So, I will consider these two ratios. Following here, how do I consider? We know by the given data, AB by PQ is equal to BC by QR. So, how we are writing this, children? By the given data we know. Now compare these two. What do you remember? Your axiom 1 you remember. What is that? Things which are equal to the same thing are equal to one another. So what you can say? AB by PQ, AB by PQ both are equal. So I can equate these two. Are you able to follow, children? This we got by these two triangles. And this ratio I wrote by the given data. Why? In order to substitute that ratio here. Okay. So now, therefore, AM by PN is equal to BC by QR. Okay. Now let's continue here. Substitute above ratio. Substitute in equation 1. That will be area of triangle ABC by area of triangle PQR is equal to, what do you have? BC by QR into, see there children, BC by QR into AM by PN there. So in the place of AM by PN, I am going to substitute BC by QR. BC by QR. Therefore, that will be BC by QR into BC by QR. 2 times multiplied means what you can say? Whole square. Area of triangle ABC by area of triangle PQR is equal to BC by QR whole square. Hence, it is proved. This is one of the very important theorem, Pythagoras theorem. Let's see the statement here. In a right triangle. So let's draw here right triangle. Okay, this is a right triangle, perpendicular. So in a right triangle, the square of the hypotenuse. Where is hypotenuse? The side which is opposite to right angle. That side we call it as a hypotenuse. So let's mark here A, B, C. The square of the hypotenuse AC square is equal to the sum of the squares of the other two sides. That is the statement of Pythagoras theorem. What does it say? It says that in a right triangle, the square of the hypotenuse. So look here into proof, I'll write that. Square of the hypotenuse means AC square is equal to the sum of the squares of the, understand the statement? Hypotenuse square is equal to sum of the squares of the other two sides. What are other two sides? AB square plus BC square. This is the equation we need to prove. Okay, so let's start our theorem. What is that? By given data, given right angled triangle. See here, right angled triangle, you can give the symbol like this also. Right angled triangle ABC. ABC. Right angled. Where it is right angle? At B. In right angle triangle ABC, it is right angled at B. Now, what to prove? Hypotenuse square is equal to sum of the squares of other two sides. Construction. Do we need any construction? Yes, we need construction. From right angle, draw a perpendicular. Let's mark D. Similarly what we have done before theorem, same manner, but here only two cases we do for this theorem. So, what is the construction I have done here? Draw BD perpendicular to AC. Draw BD perpendicular to the AC. Next, how do we start our proof? Consider triangle. You can write right triangle also. Triangle ABC. Right triangle ABC. And what is one more triangle? Let's take this triangle. Cut the point here. D. Lift it here. Again, same manner. D is here. So try to place side by side. That makes right triangle ADB. This is right angled triangle ADB. So let me draw the figure here. ABC, big triangle, and one more small triangle ADB. ADB. Okay. Now compare these two triangles in triangle ABC and triangle ADB. So what I can say here? I can say angle B. Instead of writing only one letter, I'll write this. Angle ABC is equal to angle ADB. What is the reason? Perpendicular or given, or you can say by construction you can say. Okay, we made, this is given, angle B is given, angle D is, we have done the construction. This equal to 90 degrees, children. Next angle, angle A, angle BAC is equal to, angle BAC is equal to angle DAB. How we are saying that? This angle is right angle and these two angles are common angles of a two triangles, corresponding triangles. So therefore what I can say? Right triangle ABC similar to right triangle ADB. By what? By angle similarity criteria. Okay, in always when we are writing theorem, children, these are all right reason side. statement one side and reason one side we used to have before. But now combinedly they are writing. Side beside this only we are writing. If you want, you can split reason separate and statement separate also you can do. Now these two triangles are similar by angle-angle similarity criteria. If they are similar, what do you remember? The ratios are in proportion. Which ratios? I said have to see the ratio. Only two ratios I want. How can you observe the ratio? So in these two triangles, which side is common? AB there in two triangles. Here in this triangle AB is here. And in this triangle AB is at hypotenuse. So try to take these two ratios in two triangles. So let's take here AB by AD is equal to AC by AB. Now cross multiply. AB into AB is equal to AD into AC. AB into AB. AB square is equal to AD into AC. Mark this first equation. Mark this first equation. Similarly, we are going to take another pair of triangles. What is another pair we are going to take here? Consider right triangle ABC and right triangle. See here I have said, no children, how do you compare this triangle? So lift this D. Okay, if you lift this D and place here, you may get same manner, or you can lift this B and keep here, same manner you get. So lift this D and put it here, what happens? D, and this is right angle. So now this picture and with the big triangle place aside. So let me mark here, that is BDC. Now take the figure. A, B, C, and this one is B, D, C. B, D, C. Now what happened here? Observe these two figures. I can say A, B, C is equal to angle BDC. By what children? Perpendicular means 90 degrees. Then next, is there anything common? Angle C is common. That means angle BCA is equal to angle DCB. What is the reason? This is the common angle. Okay, these two angles are 90, these two angles are common. Therefore, what I can say? Therefore, the two triangles are similar. By what criteria? Angle-angle similarity criteria. I can say that right triangle ABC is similar to right triangle BDC. By angle-angle similarity criteria. Okay, now if they are similar, what do we remember? The ratios are in proportion. Which ratios? Observe common side. Where is the common side here? BC. Right? BC is there in two triangles. So BC is at the base and here BC is at the hypotenuse. So which two sides? These two sides I need to compare. So let's take here BC by DC is equal to AC by BC. Cross multiply BC into BC. BC into BC is equal to AC into DC. That makes BC square is equal to, I may write DC into AC also, no problem. This is second equation. Now observe 1 and 2. AB square we got, BC square you got. But what I need to prove here? AB square plus BC square. So now what we are going to do? Just add the two equations. Add equation 1 and 2. What do we get if we add? AB square plus left hand side add here AB square plus BC square is equal to, now right hand side add AD into AC plus DC into AC. So now in these two, what is common? AC is common. Take out common. AB square plus BC square is equal to, if you take out AC common, what you are left with? AD plus DC into AC. AC have taken common. What is AD plus DC? AD plus DC is nothing but AC, big line. AD plus DC is AC. So in this AD plus DC, substitute AC. AC into AC. AC into AC, it will be AC square. Finally, AB square plus BC square is equal to AC square. Okay, if you want, any time you reverse the equation. So where shall we write here? So let me bring the equation here. AC square is equal to AB square plus BC square. Finally, hence it is proved. Hence it is proved. With this, we are going to end our theorem. Theorem 4.1. The tangent at any point of a circle is perpendicular to the radius through the point of contact. What did they give in the statement? They have given us a tangent and they have given a circle, point of contact. They asked us to prove that from the point of contact, the radius is perpendicular. Okay, the tangent where it touches the point, that is the point of contact, is perpendicular to the radius we need to prove. So, as usual, 5 points which are important for your theorem. This is your statement, data, to prove, construction, proof. Okay, let's start your data. What is given in the statement? Given a circle with center O. Let's take a circle with center O. Tangent xy to a circle at a point P. xy is a tangent to a circle at a point P. Tangent touching the circle at one point, right? That one point is P. That is point of contact. To prove, what we need to prove? We need to prove that the radius is perpendicular to the point of contact of a tangent. That is, OP is perpendicular to XY. Construction. Did we do any construction? Yes, we have done a construction here. So, what is that construction? Mark a point Q. Take a point Q on XY other than P. See children, Q point you take anywhere on this tangent. You take Q here, but not on P. Other than the point of contact, you mark anywhere one point and mark it Q. Join OQ. From center you try to join. Then, what is your proof? How did we start our proof? Q lies outside the circle. So now, you can see this is what children OP, radius. Then what will be this one? Radius. But this much far away your point Q. More than radius, this distance and this distance, check here carefully. These two will be equal. Up to here it might be equal. Then this distance, this length is extra. So what you can see? OQ is longer than OP. Q lies outside the circle. OQ is longer than radius OP of the circle. Therefore, OQ is greater than OP. That's it. Now you can observe directly in a circle all radius are equal. OP, if I join this Q, more than OP it was there. So I can say that OQ is longer than OP. Since this happens for every point on the line, anywhere if you mark Q, children. If you mark here Q, this much length extra. Here if you mark this much length, it will be extra. Anywhere you mark Q, the length of OQ is greater than OP on the line XY except the point P. We should not mark a Q on P. Therefore, OP is the shortest of all the distances of the point O to the points of XY. So, due to this is smallest distance when you join. Therefore, by the theorem, what I can say here, children, OP is perpendicular to the tangent, that is XY. So, once again, look here theorem. There is nothing there in this theorem, children. Look here carefully. The tangent at any point of a circle is perpendicular to the radius through the point of contact. The tangent at any point of a circle, if you draw anywhere tangent, children, the tangent where it touches the point, that is the point you need to consider. Join to the center, right? Radius you are going to get. Assume another point on a tangent. Try to join from center. Then this is the shortest length when you take other point and if you join, comparing to these two lines, this radius will be the shortest. So let's see once again your statement. The tangent at any point of a circle is perpendicular to the radius through the point of contact. And what is the given data? Given a circle with center O, tangent XY of a circle at a point P. And what is the thing we need to prove here? We need to prove that OP is perpendicular to tangent XY. Construction. Take a point or mark a point Q on XY other than P. Other than P, anywhere you can mark that Q. Join OQ. Means we need to compare OP and OQ lines. Proof. Q lies outside the circle. OQ is longer than the radius OP. Therefore, OQ is greater than OP. Since this happens for every point on a line XY except the point P, therefore OP is the shortest of all the distances of the point O to the point of XY. Therefore, by the theorem, I can say that OP is perpendicular to XY. See the next theorem, children. That is your theorem 4.2 statement. The lengths of tangents drawn from an external point. What is this word? The lengths of the tangents drawn from the external point to a circle are equal. What we need to prove here? You can see a circle with a center O and P is an external point outside the circle. So we call it as an external point. If we draw a tangent from an external point, how many tangents you can draw? Only 2 tangents you can draw. What we need to prove? The length of the tangents. Where are the tangents? PQ and PR are the tangents. Length of PQ is equal to length of PR. We need to prove that. How can we prove, children? So once again read the statement. The length of the tangents drawn from an external point to a circle are equal. What is the data given here? Given a circle with center O. Can you see the circle? Given a circle with center O and P is an external point lying outside the circle. P is an external point lying outside the circle. 2 tangents from P. What are the 2 tangents? PQ, PR are the 2 tangents. What is a tangent? It is a line which touches at only one point of a circle. What we need to prove? Length of the tangent PQ must be equal to PR. Therefore, I have written here PQ is equal to PR. Or you may write length of PQ equal to length of PR also. You can write what I need to prove. PQ length and PR length are equal. We have a tiny construction in this theorem. Join OP, OQ and OR. First, what do you know, children? You know a circle with center O and an external point P. From this point, we have drawn two tangents PQ and PR. Now, in our construction, what we have done? Join PO, OQ and OR. Join OP, OQ and OR. I have joined. So, if I join, what I can remember here? I can remember something here. What is that? I can see two right triangles. Where are right triangles? From Theorem 4.1, if a tangent is drawn to a circle is perpendicular to the radius through the point of contact. So this is perpendicular and this is also perpendicular. So I can see this is one right triangle and this is one right triangle. This is right angle, then OP is hypotenuse. Okay, immediately I can observe, compare the two right triangles here. OQ, OR. What is OQ and OR? They are radius of the circle. Are they equal? Yes, all the radius of a circle are equal. So I can say when I compare these two triangles, OQ is equal to OR and OP is common. This line equal to this line. And this is right angle. This is also right angle. Therefore, what I can say? By right angle, hypotenuse, side. That is RHS postulate. I can say that two triangles are similar. If they are similar, by CPCT, I can equate other sides also. That is PQ is equal to PR. Understand the concept carefully here, children. So, let's see the proof here. We know that angle OQP and ORP. OQP and ORP angles are right angles. How we know? These are the angles between the radii and the tangents. By theorem 4.1, I have said that angle Q and angle R are right angle. Now, consider right triangle also you can write here. Consider triangle OQP and triangle ORP. Consider these two children, first triangle and second triangle. What did we say? OQ is equal to OR, radii of the same circle. That only we have said now. Both the radius are equal. And next OP equal to OP. That is a common hypotenuse. Here I have said angles equal. If you want, you can write that also here, children. That is angle OQP is equal to angle ORP. Okay, by theorem 4.1, I can say that those angles are also equal. So, if you want, you can write this or you can skip. By right angle, hypotenuse, side. By RHS postulate, I can say these two triangles are similar. If they are similar, by CPCT, I can equate the other sides and other angles. That is PQ is equal to PR. Therefore, the tangents drawn from an external point are always equal. Hence, it is proved. Other than these theorems, some statements are also important. That is converse of basic proportionality theorem statement and converse of Pythagoras theorem statement is also important. If you practice all these theorems properly, you are going to score 8 to 9 marks. So all the best for your exams. We are going to meet in another session with another new topic. Until that, keep watching. Thank you all.